Well, good afternoon. It's a rainy day out here on the Pacific Northwest, and I'm sure that this is the first time I've actually spoken at a virtual conference. So um, everything goes completely crazy about how to introduce yourself. Anyway, my name is John Azariah. I've been working on using Orleans and stuff like that and speaking about it since 2013 or so. And so over the years, I've picked up a bunch of tips and tricks, which I'm hoping that we will cover today. Since we have a heck of a lot of ground to cover, I will take questions, but I will only address them at the end, if that's okay with you. So basically, today's talk is about how to build the Orleans applications just beyond the Hello World samples, right? In my experience, this is probably the biggest cognitive leap that somebody needs to take in order to actually build applications. Mostly getting started is simple, right? There's like a ton of information out there. Some of it's, you've got to go through the process of figuring out what overrides what. But generally speaking, there's a whole host of information. The Orleans team is already working. It's already worked its bone off. So at the moment, they're like super busy, and they have good documentation. They have a welcoming community up in Gitter, plenty of blogs, including one that recently announced Orleans 3 and so on. And you'll find going all the way back to 2013 or so, how we used to do things in the old way with blogs and videos and a ton of conference talks. Really, the problem is about trying to figure out how to learn so much about building distributed applications, all the new concepts, coming to grips with all of that, and then trying to actually make it work in production. And this is not an easy task. So while the samples are pared down, they actually obviously ignore issues that you need to be considering for production use. Just getting the concept of virtual actors takes some doing. The idea that everything should be asynchronous, the idea that everything should actually go through a standard proxied interface, and you have immortal objects that just sort of pop up on servers when you need them, and so on and so forth. There's some cognitive load associated with just understanding what Orleans is. Now, this is not a talk about that cognitive load, because I'm assuming that you're going to be either aware of what's going on, or you can pick this stuff up easily once you get started with the rest of the tooling that I'm going to talk about. But these are some of the concepts that you'll have to come across, and these are not concepts that are going to be specific to your domain, but you have to think about how you're going to apply all of these issues or apply all of these concepts to the specific problem that you're trying to solve, right? And now, once you're done with all of this, you're going to have to deal with how to actually get the thing out into production, and how you're actually going to make the thing work. Now, if you listen to some of the talks that are out there, Orleans is a tried and tested, battle-tested platform. It's been used for 8 years inside of Microsoft to run extremely critical pieces of software. So the platform's available, but there's a lot of stuff that you'll have to pick up along the way in order to make your application work properly. Now, I've kind of gone through some of this myself. I used to be part of the Azure Quantum team, and I was involved in building a schemaless database using Orleans. And I went through, because I had obviously access to the Orleans team itself, I kind of short-circuited a whole bunch of fruitless digging, but I was able to actually come up with a path that I followed, which I'm assuming is going to be similar to the path that somebody else who's going to get started will follow. And the purpose of this talk is to absolve those people of the pain and suffering that I went through when I went down this road. So the first line, which is getting the sample app going, that's fairly easy because there's a bunch of samples out there. You can take your app, get it running, run it on your local machine, make sure that it works. And then from then on, you have different levels of complexity and different families of tools that you have to kind of learn. So preparing the applications that run in the cloud basically immediately allows you to now have to worry about things like, what is a secret? How do I get the secret out there? How do I maintain this, the secrecy of the secret? How do I configure the application? How do I get multiple nodes to run and make the thing scalable? How do I provision it to Azure? What are the tools and platforms that are available on Azure to make things work? And then ideally, how do I get the whole thing to run in CI/CD so that I can actually be focused on writing my application instead of all of this other stuff, which is peripheral to the domain that I'm trying to address. So that's kind of the path that I followed. Now, so let me just get started with some basics. So let's look at the Orleans application structure. There's two pieces to it. There's a silo, there's a client. The silo and client share an interface. That's the protocol with which the silo and the client are going to talk to each other. And the silo provides an implementation of that interface. And you may have multiple silo instances lying around, which have stateful objects that actually act as the interface as the implementation to the interfaces that have been provided. And on the client side, you can have fewer clients than silos or more clients than silos, depending on the kind of application that you have. And you'll end up with client code that uses the objects, but through the interface. And the whole magic of Orleans is to make sure that the object that you think you're talking to is actually on your machine, when actually it may not be. It may be on some machine unknown to you in a cluster somewhere. And that's the whole beauty of this abstraction, right? Now, if you want to, that's the code structure of the thing. So already you can see that there's some complexity with, it's not just a simple project where you can like hit F5 and make the thing work. There's components to this piece that we need to worry about. So the code structure kind of looks like this. Now, when I built out an application by hand, I kind of more or less worked this stuff out. If I wanted to have a web API or an HTTP front end, where an ASP.NET front end to this, I would organize it in this fashion. So there would be a controllers project, the main project itself, the grains, because these grains they have to have a contract and implementation that lives on the silo. And then obviously we want to test the thing, so we have some test projects. And so the dependencies and the folder structure kind of look like this. It's not super complex, but it's not super simple either. Now just getting to this point and making sure that the right references and the right project bindings are in place is itself non-trivial. Now, Orleans actually is extremely flexible in the way in which you can structure it. You can structure it how you want. It doesn't have a strong opinion about how you should host it, how you should deploy it on what Azure or what AWS infrastructure you want to deploy the thing on. Orleans is just really super flexible. Now, while their job is to actually be super flexible and not have an opinion, somebody who has actually gone through this process and had the pain and suffering of actually getting something working, in order to bring other people on that journey quickly, I am super opinionated in contrast. So, for example, you can have, as we showed in the earlier slide, silos and clients separated completely and talking over a network. You can have that. It is a completely supported configuration. I don't like it. Now that we have .NET 3, we have the ability to co-host the silo and the client together so that you have a single executable that both acts as the silo and the client and talks HTTP to its customer, and you don't even know what's happening inside. Now, this is very good for multiple reasons, but performance is actually one of those key things because you have a co-hosted client, you don't have a serialization problem. you don't go through a serialization workload in there. You don't go through a networking workload in there. It's actually a call that happens in process. So it's a heck of a lot faster, and it's actually much easier to get started with this. Now, obviously, I have that opinion because I'm trying to address the 80-20 rule. A lot of applications can actually be quite comfortably built using this co-hosted approach. And so I'm going to advocate that you follow that. We're going to use that as the example going forward. Right? Now in runtime, if you have this co-hosted approach, you'll end up with this kind of situation where you have to have multiple silos or multiple silo and client pairs actually cooperating with each other. And so it would look something like this. You put a load balancer in the front and hook up all the clients to talk through the load balancer. So you have your get requests and your get results going out through that. And on the other side, the silos need to talk to each other because that's how the Orleans infrastructure works. And you'll notice that they've grayed out the arrows between the client and the silo because now those are about as fast as you can get. They're in the same process. You actually know that you're going to talk to an object, but that object may actually live on another silo. So your silo must be able to communicate with it over a network, which means that each of these three boxes at the top, the middle, have to be individually addressable. They should have their own IP address and they should be able to talk to each other. So that is kind of a hard requirement. You can't get around that easily. Also, the silos need to persist grain storage. So they need a connection to some possibly internal virtual network that allows them to talk to storage. And then there's the whole clustering mechanics, which I'm just talking about, which involves having each silo be addressable so that the silos can gossip amongst themselves. And you need kind of this architecture for virtually every application that you build with Orleans. Because even though you use some of the more sophisticated tools and the more sophisticated concepts that are present, you're going to need to have the individually addressable silo as a hard requirement. And that puts some limitations on what kind of Azure services you can use to host this thing. Now, given that that is the problem, right? We want to find a solution that we can evolve. Now, when I went through this whole process of actually sorting out how to get the silos to talk to each other and so on and so forth, I experimented with a ton of offerings from Microsoft. I worked with Service Fabric, I worked with VM scale sets, I worked with a whole ton, Azure, the web service environment, and then Kubernetes. Finally landed on Kubernetes. And then as I finished writing the project that I'm working on, I realized that virtually everything about the infrastructure and the structure of the application is completely agnostic to the project domain. So I decided that I would basically reuse some of that work and make it publicly available for everyone to use. Now, bear in mind that I've been doing this for a long time, so there's a lot of work that has gone in. So this is effectively distilling, nearly 10 years worth of work or 8 years worth of work into getting an Orleans application going. So that's what Orleans Universal Silo is. This is going to be part of the Orleans Contrib project, which is the community project that contributes non-canonical pieces of Orleans to the community. And here are the links. Now I'm going to share out everything I'm going to share out the PowerPoint and so on when I'm done, but these are the links that are available. And you can go and take a look at the project, and you'll be able to see that there is a GitHub page over here, which basically has a quick README to get started. There's documentation in place where you can actually follow how to set up everything. And a good portion of today's talk is actually me walking through this process with you to make it easy. Now, what we did was we created a library for all the pieces that we can abstract away that allows us to give a sort of a default implementation that someone can override if they need to, but which will work out of the box, a batteries included kind of approach, and a set of templates. Now, this allows you to basically do .NET New on the thing and then do a .NET install with a given thing. So with a given layout. So that's kind of what we're going to do as part of this talk. Now, before you get started with any of this, it's important to get your work environment set up. So there's nothing like outrageously difficult about this. So if you go in here and take a look at what it takes to get your work environment set up, it's, let me just go to the documentation. I'm sorry. So if you go to the documentation, there is actually some information about how I worked and so on, but there's the dev environment. And most of the stuff that we're talking about will be cross-platform and open source. To the extent possible, these tools will basically work. So you need Visual Studio Code or Visual Studio, Git for Windows, PowerShell, and the only sort of exotic tooling that you'll need is Make. Please don't worry, you will not be asked to write any Make scripts. You don't need to do any of that. You'll just need Make because I packaged most of the information in terms of the scripts that need to be run in a Make file because it's easy to do it that way. You'll also need Docker, and eventually you'll need access to Azure. So that's effectively one of the things that you need to get started before you go. I've obviously done that. And I'm obviously going to help you if you have a problem with this in the future. Now, getting started, let's see, we have about 10 minutes left. So these are the commands that you would run. Basically run a .NET install, which I'm going to do right now. So I'm going to do .NET new install orleans.contrib.universal silo.templates. And this will actually go off and bring it back from GitHub, from NuGet, and it will create these 4 project templates for you. Now, as I told you, you have the ability to create standalone clients in silos. You have the ability to also create a project that has a standalone silo and a standalone client as part of the same project, sharing the same DLLs and so on. But this is what I want to care about. I want to care very much about the Orleans Web API one, which basically has a Web API client stuck on top of a silo in the same host. So you're going to get that. You're going to make sure that these templates are available, and then you'll be able to proceed to the next step. And we're going to do that now. So part of this is like live coding, so please bear with me. So I'm going to go in here and create for me. I'm using Git Bash, by the way. I've just hosted inside Windows Terminal because it's easy to do it that way. I'm going to create a Scratch folder, so there's nothing inside. I'm going to now create a .NET New Web API minus name. I'm just going to call it conflict because we're all going around with grains and silos and so on. So want to bet it, there's conflict, right? And now this is better than a template or a tutorial because we're not talking about individual concepts. We're giving a kind of prepackaged solution that you can use as the foundation that addresses a lot of the issues that you need to address inside in a production environment, like making sure that logging works, making sure that App Insights works, and its storage is hooked up correctly, and all of that kind of thing. So this is sort of batteries included, get started kind of thing. Let's just go into conflict here. And then let's actually let's do the first thing. Oh, I do beg your pardon. It's not Web API I want. It's Orleans Web API. Okay. And you'll see that there's a whole ton of stuff in here, but the first thing you're going to do is do a make init on it. And what that will do is create a Git branch, which you can now see is here as it's listed as master. You'll create a Git branch and a Git commit. And that's kind of a very important thing that you need to get started with. Now I can run this thing and you can take a look at what it looks like in code. Well, actually, let me just start the solution itself. This should fire up Visual Studio and give us the ability to actually run this within a project like you would expect the project to work. Now, I will spend about 2 minutes actually talking about some of the things here. So this is a program that is there. There's the controllers and the grain. And what I've done is I've created a dummy grain that knows how to calculate, add two numbers. And the contract for that is basically just something that takes a left and a right and adds it and gives it back to you. And the implementation is like super complicated, but it does what it needs to do. Now, what I want to point out here is that there's testing is always in Orleans is a integration test. So we actually, what we'll do is we'll build this thing and we're going to fire up 2 Orleans clusters automatically as part of the game and test all the grains that we're going to create. And so when you create the tests, make sure that you try to use property-based testing when possible. So the examples have property-based testing in them, but they actually run against a cluster that is actually spun up for testing. So this batteries include approach already makes it much easier for you to get started. You already have the ability, for example, to get a testing infrastructure piece in there and so on and so forth. If I now run this thing, I should get a browser. And that should actually give me an application that's working. So if you take a look, you get a whole bunch of diagnostics that come up. And now you can go in and do a localhost Swagger, and that should actually host up just a moment. Yeah, so localhost 5000 Swagger gives me this, which now has the endpoint that I want to create. I want to be able to, if I want to test to see whether my adding function works properly, I can do 12 plus 12, execute it, and I expect to see 24 show up over here shortly. Oh, the first gremlins for the fail to fetch. Well, never mind. Let's move on. So, oh, the application shut down. This is interesting. You'll find that debugging this thing is actually going to be part of the problem. So I'm just going to move straight along and show you how you can run this thing with different environments. So let's see, I've got like another 3 minutes. I'm just going to walk through and show you what you need to do. So if you went down and got this, you would get the Orleans dashboard and the Swagger endpoint to give you the thing. And then, of course, you would look at what it would do. So our dev workflow starts looking a little bit more complicated as you go along. This is what I was trying to point out earlier, is an iterative process. You do development and testing inside of Visual Studio, and then slowly you move further and further to the right, where you do a .NET command line, Docker containerization, and installing and running it on a local Kubernetes service, and then manually deploying it to an Azure Kubernetes service where the scripts that we have actually will provision the thing for you and get it to work, and ultimately set it up for CI/CD so that when you commit to your repo and push to, say, GitHub, you should be able to deploy that on a tag or something to your Kubernetes service. That is what the set of tools allows you to do. So I'm going to, in the interest of time, because we have literally 3-4 minutes, I'm going to zoom through the slides. These are the make targets that are available, which basically allow you to test your application on .NET, Docker, a local Kubernetes deployment, and then a manual Kubernetes deployment. Now, with a manual Kubernetes deployment, you need the Azure CLI tools because you know all of the interaction with Azure goes through the Azure command line interface. So what I recommend is instead of that, use 2 shells for this and use this mechanism, which actually uses the Azure CLI Docker image to fire up an interactive shell and allow you to do whatever you need to do. The instructions for all of this are actually like well documented on the website, but effectively this should allow you to walk through and provision. In fact, this thing will provision this set of scripts. The AZ new proj and the AZ new org will actually talk to Azure, set up the Kubernetes cluster, set up all of the wiring involved associated with it. And you don't have to actually worry about that because none of that's actually unique and idiosyncratic to your application to begin with. Once you get the domain of your application sorted, you can actually then use these tools as the foundation and then build up on top of that to whatever else you need. Ultimately, you can actually just deploy to the Azure Kubernetes service. I know I'm like hand waving a bit here, but I'm going to just show you something that I prepared earlier. So if I take a look at my my Kubernetes environment, I'm just going to set the Kubernetes context on my thing to something that already exists. And I can show you that it exists is because I've got these 2 resource groups that got created by the scripts with a storage container registry, analytics workspace, storage, and the cluster itself. And I can actually get this to show you, but this thing is actually the thing that's hosted on Kubernetes. And this one definitely knows how to add a couple of numbers together. And you'll see that it is actually 33, which is exactly what you want. And if you take a look at the Kubernetes service, you can actually see that there's node pools have been set up correctly, all of the networking stuff, the workloads. You can take a look at how many pods are running and all of that from within the service. And all of this stuff got set up automatically by just using the tools that I've created in the makefile. So that's actually the talk, barring one call to action. The next steps for this project, please try these templates, improve them, pull requests are welcome. I'm working on trying to get the CI/CD stage sorted. There's a work in progress. I'm also trying to generalize this approach for non-Orleans .NET generic hosts and trying to figure out how to integrate it with Project TIE, which you've probably heard of or will hear of shortly. It was announced at .NET Conf today. And then, of course, if you have any community suggestions, please let me know, and I'm happy to take it forward. I'm sorry this was all I could do in a very, very short time. but I'm happy to take questions in the hallway track and so on. Thank you very much.
All right, thank you, John. We have one question on the chat. I'm not an Orleans expert at all, so I'm just going to parrot it. It says, using Orleans for a long time, have you experienced split brain scenarios a lot of times? If so, what's the best strategy to deal with them?
Yes. So split brain scenarios happen when you don't partition your workloads properly. And the ideal way of doing it is to basically to shard your workload in such a way that it will live for as long as possible on one cluster. And that cluster basically lives in the same virtual network. So split brain scenarios are fairly rare at that point. Split brain scenarios are much more common when you have silos, clusters of silos that are geographically separated, that assume that the work is actually going to be shareable equally on all nodes. And you don't want to think of your application like that. You should try and maybe shard out your work so that most of your work is being done by primary cluster, some by the secondary, and then kind of have a hot kind of failover mechanism. And if you shard it that way, then split brain becomes much less likely. But I'm happy to talk to you in more detail about what that design looks like. It's very different from the purpose of this talk, but I'm happy to have that conversation.